and create patterns and relationships. You are expected to 1- and 2-step problems involving addition and subtraction of whole numbers. So we are going to use algebraic thinking to solve some story problems. So the first story problem we're going to look at is Julia had a specific number of pumpkins. Josh gave her 4 more. Altogether, Julia had 10 pumpkins. How many did Julia start with? So we're going to think about what kind of problem is this? Are we joining? Are we separating? Or comparing? Let's talk about that as we work it out. So Julia had specific number of pumpkins. It doesn't really tell you how many pumpkins. What happens next? Josh gave her 4 pumpkins. So we're not sure how many she has to start with, but we know Josh gave her 4 pumpkins. So the change is going into the start number. So we do know she has 10 pumpkins at the end. So we're going to work this out. By using a diagram. So we know in the start position, we're not sure how many she had, right? We do know she has 10 and that Josh gave her 4, and that's going into the start. So this is a joining problem. And by using visuals, number lines, or equations. So we're going to start by reading a story problem. Julia had a specific number of pumpkins. Josh gave her 4 more. Altogether, Julia had 10 pumpkins. How many did Julia start with? So here I'm going to teach the conception of operation process in the word problem and not have students focus on key terms. It'll help the students with word problems as they move into higher grades. Here's an example. So as we read the story problem, now we're going to ask, what is going on? So ask the students, what is going on? We'll start by putting how many did she start with? Do we know how many she starts with? We're going to use a bubble and say, we're not sure how many she started with. So we'll put a question mark in the bubble for start. do know that Josh gave her 4 pumpkins. So we know that is going into the start bubble. And what else do we know? What comes next? All together. So we start out with not knowing the start. What comes next is Josh gave her 4 more pumpkins. And then the result is she has 10 pumpkins. Okay, so we have a question mark in the start. We know that Josh gave her 4, so it's going into the start. And the result is 10. So if we were to write that into a number sentence, we could write question mark plus 4 is 10. Now, if I look at that problem, I'm going to say, that's easy. I'm just going to subtract 4 from 10 and get the answer. But students that are just learning the algebraic equations aren't going to see it that way. So we're going to give them another visual to use. And we'll do that by making a line chart. So what I'll start with is how many we know we have. And here's my line. And I'm going to put the 10 on top so they don't get confused that it's not the area of that square, of that line. Okay, so we know we have 10. What else do we know? We know that Josh gave her 4, so I can make another line right here, chart, and put 4. So this blank space right here is the unknown. So by doing this visual, we can see that we can figure out 10 minus 4 will equal our missing piece. So now we can write it 10 minus 4 equals 6. So Julia started out with 6 pumpkins. Okay, and this problem is, because it's going into the start, we call it a join. A join. Good. Now there are some misconceptions that we need to think about when we're teaching children these equations, and the biggest misconception is the equal sign. For example, misconceptions. For instance, the equal sign can mean the same as, or we can say has the same value, instead of always saying equal. That way they get a better understanding that both sides aren't equal. So when you're writing a algebraic equation like we just did, question mark plus 4 is the same as 10. That way they're not confused that it has to be equal, because we don't have this number yet. So let's that's a misconception we have to make sure we're utilizing when we're teaching children the equal sign, to make sure we're using different words like same as and the value, the same value, can have the same value. So we're going to do one more problem using a different operation. I'm going to start with this story problem. Martha has 20 Pokemon cards. She gave some to Miles. She now has 5 cards left. How many Pokemon cards did she give to Miles? So now we're going to ask, what's going on in this problem? What is going on in this problem? What do we know? Well, we know we're starting out with 20 Pokemon cards. So we're going to make our bubble, and we're going to write start, and we'll put 20 in there. And then we know she gave some, so we're taking away, to Miles. But we do know, we don't know how many she gave Miles. But what we do know, what's next? That was next, and then she now has 5 cards. So the result is 5. The result is 5. So we're going to go ahead and make another number. So I'll make, this is going to be our 20. Okay? And then we know we ended with 5. So how many did she give Miles? So we can work that problem out. This would be the algebraic sentence would be, we started with 20. She took some away. And then that would have the same value as 5. So by looking at this, we're able to, the children are able to understand that, or the students, I should say, 20 plus 5 equals 25. And 20 minus 5 equals 15. So she gave Miles 15 Pokemon cards. And another way to use a visual is you can use blocks or counting blocks. And we could use like these Legos and have them represent ones. This can represent 20. So she has 20 cards. We'll just pretend that's 20 cards. And we